For the limiting reactants experiment, we will be combining magnesium metal, so a strip of magnesium metal, with HCl. And according to the reaction 1, that will be producing magnesium chloride, which we're not really doing anything with, and H2 gas, which we are working with. The goal for this experiment is to measure experimentally the amount of H2 gas produced, its volume, and to compare that volume to what we would calculate would be produced. Now, to calculate the volume, well, we have to, since we have two reactants, we have to determine which is the limiting reactant. So, with magnesium, we're going to weigh our strip. So we'll have it in grams. And then with the molar mass of magnesium, we can convert to moles of magnesium. With the HCl, we will measure out a certain volume of it with a certain molarity. If we convert the volume to liters multiplied by the molarity, we'll get the moles of HCl. Taking into account that magnesium to HCl are on the 1 to 2 mole ratio, we will determine which of those two is the limiting reactant. And then whichever of the two is the limiting reactant, we will determine the moles of H2 from that. If magnesium is the limiting reactant, we see that magnesium and H2 are on a 1-to-1 mole ratio. So however many moles of Mg we reacted, that will give us the moles of H2 that we produce. If it is the HCl that's the limiting reactant, we see that they're on the 2-to-1 ratio. 2 moles of HCl gives 1 mole of H2, and we will take that into account to determine the moles of H2. Now, once we have the moles of H2, to find the volume of it that we would calculate, we would produce, we will use PV is equal to nRT, reaction 2, or equation 2. And we would solve for the volume of H2, which is the moles of H2, which we already talked about how to calculate, times R, the universal gas constant, times the temperature. We will be measuring the temperature of our reaction in degrees Celsius. We convert that to Kelvin. We have the temperature. And then we would divide by the pressure of the H2. Now, the H2 gas, we will see from our apparatus, we are collecting over water. That means there's a little bit of water vapor in our, mixed in with our gas. Here is our apparatus. So what we have is a tall skinny burette with graduation marks on it so we can read the volume, and we will fill that gas burette. Notice it's a long skinny piece of glassware that's closed at one end, open at the other. We will fill it with water. We will invert that, plugging it the hole with our finger, and put that into a beaker of water. Now the water will stay put in there, but once we hook up our reaction, which produces a gas, that will be hooking up that test tube that's on the right in our diagram. We will have a pathway from our test tube to our burette, and the reaction producing H2, that H2 is forced into the burette, which displaces water, and the volume of the gas produced is what we will measure. We will be comparing that to what we calculate. Now, back to our PV is equal to nRT equation. So, we talked about the pressure. We will measure the atmospheric pressure, and the atmospheric pressure will turn out to be the total pressure, P sub total, that is in our burette, which is equal to the pressure of just the H2, that's the one we want, plus the vapor pressure of water. So the pressure of H2 equals the atmospheric pressure minus the the vapor pressure of water. The atmospheric pressure we will measure in the experiment, and the vapor pressure of water, well, we will look that up in the appendix. It depends on temperature, so we'll measure the temperature of the water, which we assume is the temperature of the gas in our burette, and look up in the appendix the vapor pressure of water at that temperature. Subtract those two and we have the pressure of H2. So carefully read through the experimental write-up, what the steps are so that you know what to do, how we've collected the data when you watch the video. Okay, the pre-lab, as usual, is not due, but let's talk through this one. It's a little complex. So what type of reaction is occurring? Magnesium solid has no charge. So we have magnesium with no charge. Notice the product that it becomes is Mg2+. It now has a charge. So it has lost 2 electrons. A redox reaction has occurred. Go back to the reactant side, the HCl. There, the H plus it's H plus and it's Cl minus. So we have hydrogen with a plus charge. But when we look to the product, what it becomes H2, the gas with no charge. So it has taken on the electrons that magnesium has given up. So it's a redox reaction. Okay, problem number 2. In an experiment similar to ours, 0.0338 grams of magnesium metal is added to 20.0 mLs of 0.521 molar HCl in a test tube. The reaction is shown in problem 1, so the reaction that's occurring, the same one we've dealt with. And the gas is collected over water. The temperature of the gas is 24 degrees Celsius, which is also the temperature of the water. And the pressure is equalized to atmospheric pressure, which is 753.2 millimeters of mercury. So in the appendix, at 24 degrees Celsius, we would find that the vapor pressure of water is 22.38 millimeters of mercury. Okay, first off, we calculate the moles of Mg and HCl present before the reaction takes place. So for that, for the magnesium, we would convert those 0.0338 grams of it using the molar mass into moles of magnesium. For the HCl, we would convert the 20 mLs to liters and multiply it by the molarity of the HCl. That will give us the moles of the HCl. Using the limiting reactant, calculate the moles of H2 gas produced. Alrighty, so we have to decide which of those two is the limiting reactant. So we would take the smaller of the two numbers, which turns out to be the magnesium, and we would convert moles of magnesium to moles of HCl needed. You see the 1:2 ratio between the magnesium and the HCl. That would give us the moles of HCl that we would need. Well, if we compare that to the moles of HCl that we have, we would find that it is much smaller. That means the HCl is in excess and the magnesium is the limiting reactant. So that allows us to answer C, the magnesium. Now back to problem B. So that means we have to calculate with magnesium. So we would go from moles of magnesium to moles of H2. We see they're on the 1:1 ratio. So that would give us the moles of the H2 that would be produced. Using the moles of H2 gas produced by the reaction, what volume of pure hydrogen gas in mLs should be collected? Remember that the gas is collected over water. Okay, so for this problem we use PV is equal to nRT. We solve for V, so that's equal to nRT over P. Well, for the moles of the H2, we have that from problem B. R we always have the value of R, the universal gas constant, times the temperature we've converted to Kelvin, and then we divide by the pressure. Now, as we're reminded, our gas is collected over water. So we go back here, we have the atmospheric pressure, 753.2 millimeters of mercury. We have the vapor pressure of water, 22.38. We subtract those two, and that equals the pressure that we would put in for D. So that is how we'd work through those problems. You don't turn in the pre-lab. But, of course, you'll be turning in the report. So the experimental data, you should be able to get all of that from the video, the experiment video, and using Appendix 3, you'll get the vapor pressure of water. And then go through the calculations, much like we talked through in the pre-lab, and you have a few questions to answer. Once you're done with all that, scan your report, make sure it's a PDF file, and submit it.